In this video, I'm going to give some insights on how generative AI works. Let's focus first on generative models in computer vision and then generative models in language. There are different types of computer vision generative models. One of them is Generative Adversarial Networks, or GANs, that was proposed in 2014. A GAN is a deep learning architecture that has a generator and a discriminator, or a classifier. The generator and the discriminator are trained simultaneously through a competitive process. The best the one gets, the best the other gets. Let's see a concrete example. We are going to see how to use a GAN architecture to train a generator that generates images of cities. The goal for the generator is to create images of cities that look as realistic as possible. To accomplish this, you also need a training set, which is a collection of real images. In this case, a large collection of real images of cities. The discriminator is a classifier. It learns to classify images into real images versus generated images. During training, the discriminator is going to take as input images generated by the generator and real images. And the job of the discriminator is to correctly classify the images into real versus generated. Notice that the more realistic the images of the generated are, the more challenging the task would be for the discriminator. In turn, the better the discriminator is, the more challenging it will be for the generator to generate images that look realistic. Therefore, during training, both the generator and the discriminator keep getting better and better at their tasks. Once the training process is finished, the generator has learned to create very realistic images of cities. The same approach can be used to generate images of other categories, like facial images, images from specific objects, or others. More recently, diffusion models have been shown to be very successful generative models. There are many types of diffusion models, but a key idea behind them is the following. You take an image and you gradually add noise to this image. Then you start from the noise and learn how to gradually remove the noise to generate a clear image. Once the model is trained, you can produce clear and realistic images from noise. GANs and diffusion models are just two very different examples of deep learning architectures to generate images, but there are many more. In the case of generative language models, a very successful approach for that is, given a piece of text, learning to generate the next word. This is actually the base of very well-known dialogue engines, such as ChatGPT. Your data are large collections of text, and the model is trained for the following task. Given a piece of text, predict the next word. By applying this process recursively, you can produce long text sequences. With large amounts of text, you can train this model to produce high-quality text. We have seen examples of vision generative models and language generative models, but there are also models that can produce other types of signals or data from other modalities. For example, we can also train generative models that produce data on the audio modality, such as music or voice. We always need large amounts of data to train these models. Once the models are trained, they are able to generate novel data. For example, unseen images, videos, texts, or audios.